Hello and welcome back to lesson 3.5. Yes, we're going back in time to lesson 3.5. I told you we might do it because it's a good lesson. In the previous task, you were asked to justify some claims by writing paragraphs to explain how various figures were constructed. Oh yeah, remember these? You're looking at diagrams, you're saying, well, they must have done this first, and then they must have done this second. How those constructions convinced you that the claims were true. Perhaps you found it difficult to say everything you felt you just knew. Sometimes we all find it difficult to explain our ideas and to get those ideas out of our heads and written down on paper. But it's a great skill. Organizing ideas and breaking complex relationships down into smaller chunks can make the task of providing a claim more manageable. One way to do this is to use a flow diagram. But then break which one doesn't belong. Read each definition and examine the accompanying diagram. Think of a reason why each definition might not belong with the other three. Okay, in a triangle, an altitude is a line segment drawn from a vertex perpendicular to the opposite side, or an extension of the opposite side. Oh, they're saying like, if a triangle looks like this, this is still an altitude, even though it doesn't actually touch the opposite side. Perpendicular from a vertex, and I think and perpendicular would work here. Okay, so that's an altitude. Here, where's here? Is there any other altitudes? No. So triangles usually only have one internal altitude, if it's a obtuse one, I guess. Let's look here. Here would be an altitude coming from this vertex to this, if that was perpendicular. So they don't have to be like up and down. They can go any way they want as long as they go from a vertex and then are perpendicular. Not perpendicularly bisecting. It's not bisecting, but it is perpendicular. In a triangle, an angle bisector is a line, segment, or ray drawn from a vertex that cuts the angle in half. So this one's about splitting the angle. Well, we already know what an angle bisector is. So in a triangle, a median is a line segment drawn from a vertex to the midpoint of the opposite side. These are fun. So it doesn't necessarily have to be, it's not perpendicular, except in an equilateral triangle. But it goes from a corner to the middle. Whereas this one goes from a corner to make sure you hit perpendicularly. This one's okay with being slanted as long as it hits the middle. In an equilateral triangle, these are the same. It's the altitude and it hits the middle, but only in an equilateral. Otherwise, they're different. We already know what a perpendicular bisector is, so this one goes from the middle to wherever. Travis used a compass and a straight edge to construct an equilateral triangle. He then folded his diagram across the 2 points of intersection of the circle to construct a line of reflection. Travis, Tahani, Carlos, and Clarita are trying to decide what to name this line segment from C to D. Travis thinks the line segment they have constructed is also a median of an equilateral triangle. Tahani thinks it's an angle bisector, Clarita thinks it's an altitude, and Carlos thinks it is a perpendicular bisector to the opposite side. Let's see if I can pull this up. Oh my. Are we missing some words here? If you have the stapled packet, the words are there, they're just not bolded. Altitude is a line segment. A median is a line segment. Vertex to midpoint. So altitude stands tall, perpendicular. A median hits the middle. Altitude stands tall. Median hits the middle. So Travis thinks it hits the middle, which would make these the same. Tahani thinks an angle bisector, which means it would split this in half. Clear thinks it's an altitude. Altitude stands tall, so it's perpendicular. Carlos thinks a perpendicular bisector of the opposite side. Well, that would be Carlos' things would be true if both Travis's thing and Clarita's thing is true. If it is an altitude that stands tall at 90 degrees, that makes it perpendicular. If it is the median, it hits the middle, so it's a bisector. So this makes it perpendicular, this makes it bisector. If they're both true, then Carlos's thing is true. The four friends are trying to convince each other that they are right. A flow diagram shows the statements that can be written to describe the relationships in the diagram, or conclusions that can be made by connecting multiple ideas. You will use the flow diagram to identify the statements each of the students might use to make their case. Answer the following problems about what each student needs to know about the line of reflection to support their claim. To support his claim that the line of reflection is a median in the equilateral triangle, Travis will need to show that median hits the middle, so we need to say this line hits the middle of this line, and if it did hit the middle of this line, then A to D would be the same as B to D. Let me take a peek here. I'm going to say AD. Remember when in geometry, when you just have two letters, it stands for the distance between them. So that's a number, equals BD, another number, which if this is true, then there's another fact that's true. The segment AD is congruent to the segment BD, because that's the definition. This is the definition of congruent. So we could, if we get to either one of these, we can make it work. To support her claim that the line of reflection is an angle bisector of the equilateral triangle, Tanya will need to show that this angle ACD is the same as BCD. The measure of angle ACD equals the measure of angle BCD. And then we will be able to say that angle ACD is congruent with angle BCD. I don't know. Again, I don't know which of these is easier to prove, but once you prove one of them, you can get the other one. That the measurements, I think we need to say the measurements are equal to show that it's a bisector. But if we can show that the angles are congruent, then we can know the measurements are equal. Then we can say it's an angle bisector. To support her claim that it's an altitude, she'll need to show that the line starts at a vertex. Well, we already know the line starts at a vertex. That's evident from the diagram. We need to show that when it comes down here, it meets at a 90. That will make it an altitude. So measure of angle CDB equals 90 degrees. To support his claim that the line of reflection is perpendicular bisector of the side of the equilateral triangle, Carlos will need to show that M is CDB. This makes it perpendicular. And measure of AD equals measure of BD. That makes it split. Split the side right here. Now, interestingly, Carlos doesn't actually care if this line touches the vertex, because a perpendicular bisector of this side would not necessarily need to touch the vertex. Let me draw you another triangle. Here's a perpendicular well, it's bisecting, and now let me make a perpendicular. There, that's a perpendicular bisector on the side. It doesn't touch this corner. But the median does have to touch the corner, and then an altitude touches the corner and drops down at 90. And see how this perpendicular bisector and this altitude are parallel because they're both on 90s to this third side. Okay. How's the other packet doing? Let's check out old Stapley. Oh yeah. Oh yeah, this page is almost identical. Well, sort of. Provided is a flow diagram of statements that can be written to describe relationships in the diagram or conclusions that can be made by connecting multiple ideas. So remember, we are going to try to show that AD equals BD. We could do that if we could establish that these two half triangles are congruent triangles. We know that, let's see, okay, shared side, let's see, use 4 different colors to identify the statements each of the students, Travis, Tehani, Clarita, and Carlos, might use to make their case. Well, you can see here that we have AD, BD, or DB. So this is a midpoint proof. So this gets to that it is a median, because the median is at the midpoint. Also, perpendicular bisector needs this information. What about CD is congruent to CD? Oh, that's shared side. Oh, this gets to the angles, ACD, BCD. So this one will go to that it's a angle bisector. I am not on the screen. Okay. So using CPCTC, once the now we haven't got there yet, but once we get to here, the triangles are congruent, then we can say those angles must be congruent. Therefore, segment CD is an angle bisector. Okay, I'm going to pause there. See if you can figure out how you would flow down through, kind of like how I showed this flow. This goes to this, therefore it's an angle bisector. How does this flow? You can grab different colors for different, like if you're trying to prove that it's a perpendicular bisector, you're going to have to, it's a CE is a line of reflection. That gives us that D is the midpoint automatically. So it gives us this right away. So basically, let's see. D is a midpoint. So then you can go from here straight to here. So you can go around this whole thing. So who is this supposed to be? Who wants to say it's a median? Travis. So pick a color for Travis. And just starting from the fact that it's an equal, well, he doesn't even need to know that it's an equilateral, does he? Not to hit the middle. He just needs to know that it's a line of reflection. That means it's a midpoint. That means that's congruent, and then done. So his is really easy. What's the flow through these statements to get to that's an angle bisector? We already know this last step, but how does she get here? Flow down through, does she need to know this? Does she need to know this? What does she need to know? Okay, give it a shot, and then we'll come back in part 2.